All right, today we're going to tackle a huge question, one that every single programmer has to deal with, whether they know it or not. When your program needs to remember something, where does it actually put it? We're diving deep into the stack versus the heap.
I mean, look at this. It seems so simple, right? You write int x equals 10. You declare a variable, you give it a value. But behind the scenes, your computer is making a really critical choice. See, it's got two main places to put that 10, a super organized spot called the stack and this vast, flexible space called the heap. And believe me, understanding that choice is the key to writing code that's not just fast, but stable. So let's get into it.
Okay, first up, let's talk about the stack. To really get it, I want you to picture a hyper-organized librarian. You know the type. They're at a small, perfectly tidy desk. Every book has its place, and they can grab it and put it back in the blink of an eye. That, in a nutshell, is the whole philosophy behind the stack.
So what is it officially? Well, the stack is a special area of your computer's memory that stores temporary variables. Think about all those little variables you declare inside of a function. The most important part, though, is that it's managed for you. The CPU handles everything automatically, which makes it incredibly fast.
And the core principle of the stack? It's a simple little acronym, LIFO. Last in, first out. It's just like a stack of plates at a buffet. The last plate you put on top is always the very first one you take off, right? The stack manages your program's data in the exact same way. Let's see how that actually works.
Okay, check this out. Your program kicks off with its main function. All of its variables, like age and salary, get pushed onto the stack. Then let's say main calls another function. Bam! That function's variables get pushed right on top of the old ones. But as soon as that second function is done, its data is popped right off the top and just vanishes. Poof. Gone forever. And finally, when main finishes up, its variables get popped off and the stack is perfectly clean again. Last one on, first one off. It's a beautiful system.
So to wrap up the stack, it's blazing fast. It's totally automatic, so you don't have to worry about cleaning up after yourself. But, and this is a big but, it's got some serious limitations. It's pretty small, which can lead to that infamous Stack Overflow error you've probably heard of. All its data is temporary. It disappears when a function ends. And here's the kicker. You have to know the exact size of your variables before the program even runs. And that rigidity is exactly why we need another option.
And that brings us to player number 2, the heap. So if the stack is that neat librarian's desk, the heap is a massive, sprawling warehouse. It might be a little messier, maybe a bit slower to find what you're looking for, but you can store pretty much anything you want in there for as long as you want.
So the heap is this giant pool of memory that's available to your program. And what's the key difference? It is not managed automatically. This is the trade-off. You get all the flexibility and all the size you could ever want, but you give up the speed and the automatic safety that the stack gives you for free.
This really is the golden rule of the heap. You are the boss. You're in charge. You have to go to the system and manually ask for a chunk of memory. And just as important, it's your job to go back and tell the system when you're finished with it so someone else can use it.
Let's see what that actually looks like in code. On the stack, you just declare your variable, int age equals 30. Done. Simple. On the heap, though, you have to call a special function, like malloc, that stands for memory allocation, to go and request the space you need. And when you're done with it, you, personally, are responsible for calling free to give that memory back. And if you forget,
Well, you get this, a memory leak. This is the big boogeyman of manual memory management. It's when your program just keeps holding on to memory it doesn't need anymore, gobbling up more and more resources until everything grinds to a halt or even crashes. This is the great danger of the heap.
So let's sum up the heap. Its incredible power comes from its massive size and the fact that your data can live for as long as you need it to. But all that power comes at a cost. It's a bit slower, and the entire burden of managing that memory is on your shoulders, which opens the door to nasty problems like memory leaks.
okay, we've met our two players. We have the fast automatic stack, and we have the vast manual heap. So the million-dollar question is, how on earth do you decide which one to use? Well, the answer is a little more subtle than you might think, and it's really the key to mastering how your program uses memory.
You know, a lot of people think the choice is just about scope or, how long you need the data to stick around. And while that's definitely part of the story, it's not the whole story. The real deciding factor is something way more fundamental.
As Reddit user W. Gunther points out here, it's a lot more precise to think about the lifetime of the memory. The stack's lifetime is totally automatic. It's tied to a function call.
The heap's lifetime is manual. It's controlled by you. But even that doesn't get to the absolute heart of the matter.
And here we go. This is it. This is the big aha moment. The single most important reason to ever use the heap is when you do not and cannot know how much memory you're going to need before your program actually starts running.
Let's break this down to make it super clear. Compile time is when your code is being built, before anyone ever runs it. If the compiler can look at a line like int scores 10 and say, aha, I need space for exactly 10 integers, that is perfect for the stack. But runtime is when your program is actually out in the world, doing its thing. If your program needs to load an image from a user, but it has no idea if that image is going to be a tiny icon or a giant 4K photo, you can't possibly know the size at compile time. In that case, you have no choice. You must use the heap to ask for the right amount of memory on the fly.
So with that critical difference between compile time and runtime knowledge fresh in our minds, let's put it all together. It's time for a final, actionable guide on how to make the right choice every time. Here it is, your ultimate cheat sheet. The stack is your fast, automatic librarian. It's for your small data whose size is fixed and known before the program ever runs. The heap is your vast, manual warehouse. It's for large data or data that needs to live a long time, or, most importantly, data whose size is dynamic and can only be figured out while the program is actually running. And this all leads us to the single best piece of advice I can give you. Always, always prefer the stack. By default, use the stack. It's simpler, it's faster, and it's way safer because all the memory management is done for you. Only reach for the power and the danger of the heap when you absolutely have to, specifically when you don't know the size of your data at compile time.
Now, I know what some of you might be thinking. Hey, my language has a garbage collector. It handles all this stuff for me. And you're right, it does. But guess what that garbage collector is doing? It's just managing the heap for you behind the scenes. By understanding the fundamental difference between the stack and the heap, you get this deeper insight into what your code is actually doing under the hood. And that knowledge empowers you to think about performance and memory in a way you just couldn't before. And that makes you a much, much better programmer, no matter what language you're using.